Okay, let's do some rational equations. And we're going to sort these ones out using a lowest common denominator. Lowest common denominator. Now, lowest common denominator, you can find that out on page 130 of the textbook. That will give you a bit of an explanation there. Okay. So, when we have these equations, these are linear equations where you find some fractions, or more than one fraction. What you need to do is to convert each of those fractions into a form where the denominator, which is the number on the bottom, is the same. So in the book there's an example of x over 4 equals x plus 1 over 6. Now the lowest common denominator for these two fractions is 12. That is because 4 times by 3 equals 12. 6 times by 2 equals 12. So this means we now have some numbers that will convert these bottom numbers, these denominators, so this 4 and this 6, into a 12. So let's start with x plus 4. X plus 4 equals, I'll just write this out in full for you, x plus 1 over 6. So we need to convert this 4 into a 12. How do we do that? Well, what we can do is look back here, we go 4 times 3 equals 12, so we have to times this bottom line by 3. When we do this, we have to times the top by the same one. Now notice here, 3 over 3 equals 1. So effectively, we are timesing this x divided by 4, this x over 4, we are timesing it by 1. When we times it by 1, it will still have the same value, but the fraction is going to look different. So what we then get is 3x over 12, because we times the top number by the top number, bottom number by the bottom number. 3x equals 12. Now on this side, we want to convert this 6 to a 12. Well, how did we do that? That's 6 times 2. So that would be 2 times 6. Now what we do to the bottom line, we do the top line. 2 times x plus 1, 2 times 6. So we know 2 times 6 is 12. And on the top line we have 2 times x plus 1. So remember, our goal was to get the fractions in the equation to have the same denominator, so the same number on the bottom line. And that's just what we've done now. We have 3x over 12, and we have 2x plus 1 over 12. They now have the same denominator. So from here, depending on how you are with your fractions, let me write this out again, 3x over 12, 2x plus 1 over 12. Now, some of you might remember your fractions well enough to go, well, I've got 12 on the bottom line here and 12 on the bottom line here. They cancel out. Because they cancel out, we end up with 3x equals 2x plus 1. But for those of you who can't see how that works, what happens is, let's think about inverse operations. Let's say I was just trying to get this x by itself. The first thing I have to do to start doing that is to get rid of this divide by 12. One way to do that is then to times everything by 12. So we would get 12 times 3x over 12 equals 12 times 2 times x plus 1 over 12. So just to be clear, this is like back when we started. We're getting rid of this 12 on this side of the equation by applying inverse operations. We have a divide by 12, so we are then going to times everything by 12, which is what we've done here. 12 times 3x over 12. Whatever we do to one side of the equation when we do inverse operations, we do to the other side. So we have 12 times 2x over 12. But now what we've got in this form is we're timesing something by 12, this 3x, and then we're dividing it by 12. If we times something by a number and then divide it by the same number, we just end up back where we started. So if we times 3x by 12 and then divide it by 12, we just end up with 3x. Likewise on the other side. If I have 2x plus 1 and I divide all of that by 12 and then I times it by 12, we're just back to 2x plus 1. So they cancel out. That's how we get to 3x equals 2x plus 1. So now where we're at is we have, let me write this out again, we've got 3x equals 2x plus 1. There we are. Now we're at the stage where we've got to a point where we have repeated unknowns, an equation with repeated unknowns. Now if you remember from earlier, the first thing we do when we have repeated unknowns is expand any brackets. So let's write this out again. 3x equals 2 bracket x plus 1. We expand these brackets. 2 times x, 2 times 1. So there we've expanded brackets. Now, next thing, collect like terms. Now it doesn't matter that this 2x is on the other side of the equal sign. We can just move it over. And when we do, it changes signs. This is plus 2x on this side. We're going to move it to this side of the equation because then we can collect our like terms. So when we move it over there, it goes from plus 2x to minus 2x. So 3x minus 2x, because it's an opposite operation, plus 2x has become minus 2x, equals 2, because that's gone from that side of the equation. 3x minus 2x, collect our like terms, is 1x, equals 2. So there's your answer, x equals 2. So my advice is, if that didn't make sense right now, go back and rewatch it, pause it at each step, and try and follow it in the textbook.